Welcome to Brain Vision.
So in this question, we're basically given the wind chill index, which is a function W equals 13.12 plus 0.6215 T minus 11.37 times V to the 0.16 plus 0.3965 times T times V to the 0.16. So this function is in this function, T is temperature in Celsius, V is the velocity of the wind, and they're giving us that the wind speed is measured as 26 kilometers per hour. So that means V is going to be equal to 26 kilometers per hour, and with the possible error of plus or minus 2 kilometers per hour. So dV is going to be 2 plus or minus 2 kilometers per hour. And then the temperature is given to us as negative 11 degrees Celsius, and the possible error, dt, is going to be plus or minus 1 degree Celsius, right? And the reason that the error is the derivative is because this is going to be possible error 2 kilometers per hour, right? And that's because that's what error means. For every 1 hour, the error is plus or minus 2 kilometers per hour. And kilometers per hour is not velocity anymore, that's acceleration. So that's why it's going to be the derivative, right? And the same thing goes for temperature. This is the amount changed per Celsius per hour. So that's why these are the derivatives. So that means how we're going to actually solve this problem and find dW, which is the goal of this problem. So the goal of this problem is find dW, right? So in order to do that, because they're asking us to calculate maximum error of the W value, and as we talked about, error is just the derivative, so we have to take the derivative. So there we go. So let's start first here by taking the derivative of dW. So you'll see that there's two values here. There's T and there's V. So what that means is we have to take the two partial derivatives. So we have to find, in order to get dW, right? So in order to get dW, we have to get the partial derivative of W with respect to T times dt, right, plus the partial derivative with respect to W of V dV. And if you get both of those and add them together, then that will be your derivative for dW, right? So let's go ahead and find that partial derivative. So the first partial derivative with respect to T is really easy. The 3.12 becomes 0, 6.215 will be 0.6215, minus 11.37 times V to 0.6 will be 0, and finally here you'll be left with just plus 0.3965 times V to the 0.16 times dt. So that one was really easy. And then now here for our dV, our partial derivative with respect to V, we get 0 here, 0 here, but here we get negative 11.37 times 0.16, so negative 11.37 times 0.16. Or you get negative 1.8192 V to 0.16, and then it's not 0 to 0.16, it'll be minus 0.84, because you have to subtract 1, right, with the exponent rule when taking derivatives. And then you add to that your next derivative, which is this, right, and over here all you will do is 0.3965 times 0.16 once again, and then you get 0.06344 times T times V to the negative 0.84. All of that times dV. So it'll actually be plus negative here. So now that we found that, we basically need to plug in these numbers here to dw, and then that'll basically give us the error. So it's really simple from here on out. So we have to use v equals 26 kilometers per hour, dv equals plus or minus 2 kilometers per hour, but we can't use both plus and minus. So here's where it gets a little bit tricky. So when you look at these partial derivatives that we calculated here, you'll see that dt here is positive. So that means for plus or minus 1 degree Celsius, we're going to actually take positive 1 degree Celsius. But you'll see here that dv is actually negative because this part is bigger than this part. Negative 1.8192, right? That number is bigger than 0.06344. And at 1 degree Celsius, this t is basically just, at negative 11 degrees, that'll make this part also negative. So that means dv is actually going to be negative as opposed to positive here. So since it's negative, you're actually going to use negative 2 kilometers per hour for dv. So now that we got all that cleared up, let's go ahead and plug everything in, and then you'll get dw equals 0.6215 plus 0.3965 times 26 to the power of 0.16 times dt. And dt is, of course, just 1, plus negative 1.8192 times 26 to the power of negative 0.84 plus, it'll be minus, and then you'll do 0.06344 times negative 11, since that will be your temperature. So that will be minus 0.69784. And t is, we plug t in, and then we have to multiply that by 26 to the negative 0.84, and then all of that times negative 2. Right, so once we get that, we can go ahead and start evaluating on the inside. 26 to the power 0.16, 26 to the power 0.16 is going to be 1.684 or something like that. And then you multiply that by 0.3965, and then you add that to 0.6215, and that will give you 1.289 plus, now you evaluate this, 26 to the power of negative 0.84 gives you 0.064777. You multiply that by negative 1.8192, and that'll give you negative 0.11784. 11784, and then you do that again, 26 to the power of negative 0.84, and you get same thing, 0.064777, and you multiply this time by negative 0.69784, and you get negative 0.045. So you do that minus 0.0452, all of that times negative 2, and that inside part will just be negative 0. So I'll write this in another step, plus negative 0.16304, if you want to keep going, times negative 2, and you multiply that by negative 2, you get a positive number, and then you add that to 1.289, and you'll get approximately 1.615. And so what that tells us is, where's dw? Here it is. dw, that's dw, right? So our answer, after plugging in all our numbers, is that dw is going to be approximately equal to 1.6, and that will be your final answer. So in this problem, it was really simple. Step by step, all we did is first we identified our goal, and that was to find dw, and then from there we defined w, defined all our parameters, and then we realized that we have to take the derivative, and then finally we took the partial derivatives here, and then from the partial derivatives we got that d dot dv was negative and dt was positive, so then that narrowed down our values for dv here and dt here, and we realized that one was positive, one was negative, and from there it was a simple matter of just plugging in everything in their necessary spots, doing all the math, and finally getting the answer. So that was really simple on how to do that. So that's it. Yeah, all done.